Good morning, students. Today I am explaining about the next concept of the lesson, force and laws of motion, that is conservation of momentum. Before studying conservation of momentum, what is meant by momentum? Momentum is a physical quantity. Momentum is a physical quantity Momentum is a physical quantity which is the product of mass and velocity, and this momentum is denoted by denoted by P. That means P is equal to m into V. Momentum is the product of mass, m it is the indication of the mass, and V is the indication of the velocity. It is the product of mass and velocity of the object. So this is the whatever the definition of the momentum, and this is the formula to calculate the momentum. And the SI unit of momentum, SI unit is kg meter per second. So this is all about the basic information regarding the concept momentum. And now what we are studying now is conservation of momentum. We have already studied the conservation of the energy, and the conservation of the energy, it says that energy can neither be created nor be destroyed. Only the thing is energy can be transformed from one form to the another form. But here we have taken the concept of momentum, and we are studying here conservation of momentum. And conservation of the momentum, conservation of the momentum, it is to be studied like this, students. And the conservation of the momentum statement is like this. Statement of conservation of the momentum. The total momentum of two objects is always conserved. Means total momentum before collision is equal to after collision moving with, this way. The total momentum of two objects is always conserved, means total momentum before collision is equal to after collision. And this is what the statement of the conservation of the momentum. And this is to be proved by taking this illustration. Consider two balls. This is a ball A and this is ball B, and the mass of this ball is, let mass of ball A be ma, moving with velocity initial velocity UA and mass of ball B. Let this be MB, and moving with the initial velocity U. So this is what the situation we have taken to explain the conservation of momentum. And what happened is the ball started to move towards B and collided with ball B. Okay, and these two are colliding. In the second situation, ball A is colliding with ball B. So this ball A and these two balls are collided with each other, and while in collision, the ball A exerts a force FAB onto the ball B, and according to Newton's third law of motion, ball B exerts a opposite force that is to be named as FBA, but opposite in direction. Okay, and what happens is after the collision, the ball A moves with a final velocity VA, and this final velocity VB. And now FAB, we have already studied F is equal to MA, that is from the Newton's second law of motion. And if this has taken, what we have studied is FAB is equal to FBA, and now this is MA and acceleration A and minus MB acceleration factor, and now MA, this is VA minus UA by T, and this minus into the bracket MB into VB minus UB by T. And what we have taken is these two are of equal masses, and what I will do is the time factor I will cancel each other, and now it became MA into the bracket VA minus UA and equals to MB minus VB minus UB. Let us multiply MA into VA minus MA into UA is equal to minus MB VB minus into minus plus MB U. And now what I will do is I will take this whatever final momentum to the left hand side, MA VA plus MB VB equals to, and initial momentum to the right hand side, MA UA plus MB U, and this can be written like this, MA UA plus MB UB Here we got the statement. Here from this it is proved the law of conservation of the momentum. That means the total momentum before collision moving with initial velocity factor, you have to notify here. Initial velocity. Here VA, final velocity. That means this is initial momentum. Initial momentum of the two objects is equal to final momentum, and from this it is proved whatever the law of conservation of the momentum. Initial momentum of the two balls A and B, okay, before collision, that is what the initial momentum is equal to final momentum after collision. So this is very important expression, and you have to be perfect with the statement of the law of conservation of momentum, and it should be perfect by you to derive the expression MAUA plus MBUB is equal to MAVA plus MBUB. Initial momentum of the two objects is always equal to final momentum after the collision of the same two objects. Okay, and what you have to do is you have to write down these derivation in the frame notebook and practice this one. Okay, on this a long answer question it will come for 3 marks. Okay, and statement may come for 1 marks. You should be perfect this one, and in my next class I will solve the numericals. Thank you.